Hey everybody, Mr. Tannen right back with another video. Yes, okay, let's check it out. So, this was the implicit differentiation optional homework. Yes. So, remember, implicit differentiation. Some of you emailed me saying you were lost. We're going to pick right back up and continue a bit. I had some good resources I'll share with you Monday also. But remember, an implicit form of an equation is when we we don't have the function where y is expressed as a function of x. In this case, x and y could be, the function is expressed in terms of both y and x, meaning the y is not necessarily by itself. So in this case, we still differentiate with respect to x. We want to then, after that though, collect all the dy dx's on one side and then solve for dy dx. So let's look at how this is going to play out. So, well, in number 4 here, we've got something happening. And we got a few ways we could go about it. What I'm thinking, first and foremost, is product rule. Because we got to take the derivative of both sides, right? And what I notice is that on the left side, we have a product. The derivative of a constant is 0, but here we're going to have to do left d right. The derivative of y is just dy dx plus right d left. It's just 2x. Okay. So now I want to get, again, just the dy dx's by themselves on one side of the equation. This has just become 2xy. I could subtract it over. Then I would just divide by x squared. And this is what dy dx would be. But look, I can cancel out one of my x's with one of the x's in the bottom. So I would get negative 2y over x would be the derivative. So our derivatives in this case also end up with a y. But we've noticed when we're trying to find slope or the equation of a line, that's not a problem because we usually have the y value that we could use. So that was number 4. Let's take a look at 5. A little bit more going on. So again, I can just jump right into differentiating, which is quite nice. And actually, if I differentiate the left side, I could also, because we know the derivative of a sum is just the derivative of each term, I can do that like this. Okay. Okie dokie. Product rule it. It's quite similar to what I did before, but here the square is there. So left d right, that'd be 2y times x, 2xy is right, plus right. Oh my gosh, I almost fell for it. Chain rule it. Almost got stuck in the trap there, right? Left d right, so the derivative of the right is 2y, but I can't forget my dy dx because y is, we're differentiating in terms of x, so y is still a function in terms of x, so I can't get stuck in that trap. But I'm still differentiating this because I just did left d right, now I gotta do my right d left. And the derivative of x is just 1, so I don't even really need to write it. And then here I'm going to have my 3y squared, but again I'm going to have my dy dx equals 0. Subtract my y squared over. Now I just have my 2xy dy dx plus my 3y squared dy dx equals my negative y squared. And now I could factor out my dy dx here, now that I've got it in every term. And then you guessed it, we would just divide this mamma jamma over to this side. And so then I would have my derivative. Again, we can check. It looks as though we'll have a y, at least 1 power of y in every term. So we could cancel. Bam, bam, bam. So dy dx is just going to be negative y over 2x plus 3y. Okay, cool. Oh, they had a video solution for that also. That was fun. I'm starting to really enjoy this. Wow. So this is the one that I was a little bit lost in the sauce on because Jasmine, shout out to Jasmine and Maeve who submitted images of their work for this optional homework. If we differentiate both sides, let's check out what happens. So the dx of the left side. Well, we're going to get up with the chain rule. The quotient rule, as you can see. I'm just going to get into it. Hopefully people don't mind. Low d high. 1 minus 2x times the d high would just be negative 2y. Don't forget the dy dx. Minus high d low. Just be negative 2. All over low squared. I'll just leave it as so. The derivative of the right side is just 1. Okay, so let's get to work now. Oh my gosh, it just keeps jumping around sometimes. So I would get my Let's take a look at how this is going to play out. Okay, I see what you mean. So I could just first of all move this over here. 1 minus 2x. If you haven't already started watching the double pace, anytime's a good time to do that. And then that times that 1 is just that. So, well, now I could add this over. So I'm going to have this. Maybe would it make sense to maybe distribute, I guess, maybe, or become negative 2 times 1. And then I could distribute that negative, like, I could just add it over, I guess. I'll just put the y squared first. Divide that over. This is all just algebra now, and then I divide this part up. I'll basically just add that negative 2y over there to the denominator. This is one where I wasn't quite sure how the answer key got to where it was at, because this was the answer I had. The answer key had something, had this along the lines. It had 4x minus 1 over 2y as the derivative. So I'm curious how they got from one to the next. I don't know, but that's why I thought there was a mistake in the answer key. Somebody let me know if you see how they got there, because I'm a bit lost in the sauce right now. If there is a way. Okay, I'm sorry I'm losing space here. These problems are so condensed. 7 y cos of x plus y squared x equals 3x. Differentiate both sides. Product rule left d right plus right d left. And then I gotta do another product rule left d right. That's just 1 plus right d left. Don't forget my dy dx every time. Okie dokie, so this is just going to be negative y sine x. I could add that over 3 plus y sine x. I could subtract that y squared over. Now I got my cos x dy dx. And then plus my 2xy dy dx. Once I factor that dy dx out, as we're starting to see, I just would end up dividing it by this. I get, let's see, I don't know what order to put it in the end, because it'll be funky different terms. I guess we could just 3 plus y sine of x, we'll leave it like it is. All over. I lost my x here, sorry about that. 2xy plus cos x. And that does match the answer Q, so that's a good sign. I asked 1, yes. Differentiate 2x, differentiate 3y squared dy dx. 0. Bam. Negative 2x over 3y squared. Wow. So, those are all my implicit differentiation. I still feel a bit tripped up by number 6. But like I said, I even tried putting it through one of those things that will calculate it for you. And you would think they would simplify it to the fully simplified form, but none of them got this. So I'm a little bit lost how to go from there. I don't know. I guess I could separate it. I could make it this over this and this over this and see what happens, but I don't know if that's actually going to get me anywhere. But yeah, some good stuff happened. Look at all that. Hope we're going to continue with implicit differentiation tomorrow, Monday. Hope everybody's having a nice weekend. Much love.